right, so there's a lot to go over in this homework. But a lot of it I want to type. Number 12. Gallup poll in November 2008 found 59% of people in the sample said yes when asked, would you like to lose weight? This is our what? 59% is our what? P hat, which is our what words? What's the dot in the middle? Point estimate. What is our population? It doesn't really give you much, right? So the best we could write for population here is just people, which you have to use within your answer. It also does not give you a sample size. So explaining margin of error, remember we've got point estimate, we've got our confidence interval, and then that line in between is, so this is margin of error, which is also the same thing as this, the same distance either direction. So you're explaining the distance right here. The way the book said this one is if we were to repeat the sampling procedure many, many times, on average, the sample proportion would be within 3 percentage points of the true proportion. I was talking to people, and I would probably have you have written something like, that's the part I want you to talk about. Now, where it's a little bit confusing right now is of what? Because it's, if I said of P hat, that would be applying it directly to this sample. But then if I just said P, then I'm saying P is within 3% of P. So this is not one that I'm going to ask you as an interpret. I need you to understand that this is a distance that we are dealing with. This is my key word is within. Margin of error is talking about within that much in either direction. Are we okay with margin of error is the distance, the blue line, not a dot? So I don't need a perfect definition for A like I usually do for like B and C here. So now tell me what to write for B. What does it start with? We are and decimals or percent, it doesn't matter. As opposed to C, which starts with what? Of. Now, why is this problem weird? It didn't give us a sample size, so I would say also didn't give us a definite population. So I put of this many people to say, I know that the process had to be repeated the exact same. So this many people, this exact size, repeated over and over. So 95% of all possible samples of this many people, what? So I talked about this yesterday, but then I didn't let you do it yet because I wanted you to have examples written out. if I keep referencing that, what could I have done in this problem? Made a key up here and say let P. So at that point, every time that I just put P, I am referencing P is the true proportion of people that want to lose weight. So now every time I write this yellow part, I could just write P and it references that. So I didn't want you to write it out shorthand in the very first example that we did writing these out yesterday. But I don't mind from now on if you start doing that, especially because it gets really repetitive. Number 16, this is the one about fake profiles or false information on profiles. This is just going through these sentences again. Now, what's weird about this problem? There's something really specifically weird about this problem. The data is a difference of proportions, which means how many samples. 2. This is something that we deal with in another chapter, so we will get very specific about it. At this point, we're basically just seeing, can you see that you can relate it bigger or outside of the direct problems that we're doing right now? Oh. So confidence interval would be, we are 95% confident that, what would I put there? Usually I put what there? What or what? Mu or P. But right now it's not just mu or P, it is. So we're going to talk about how to better write that when we get to that chapter. But right now we're just talking about it's a difference in proportions of. You will have to specify, and this part I don't care if you do right now or not, because this is the specific to the chapter, is the direction of your difference to included. So we're 95% confident that the difference in proportions of teens, younger minus older, who included false information in their profiles, then what? How do I finish that sentence? The thing that we want you to get out of there is this a problem I would have asked you to do and find the work for? No. But do you understand how this same interpret can easily apply when we go to 2 samples instead of 1? So that's the part that you need to get as far as today. So confidence level would be 95% of all possible samples of, and this is where I don't know that you guys would have done this right at this point. We had 170 younger. We have 2 different groups with specific numbers. So you would technically have to be specific about that. Again, not my biggest concern at this point right now. Will result in an interval that captures the that same thing again. So 12 should be straightforward. Maybe a little bit funny with A. 16, you should be able to apply that fine, but it's just both of those are confidence interval, confidence level, interpret. 18 is where it starts to get really specific, and some of you may have had trouble with this while you were doing the homework, and that's okay. I need you to feel good about it by the time we finish going over it. So this is the idea of throwing the hula hoops in a pitch black room. So what happens here is I threw the hula hoop and I walked away. And I never ever found out if I got it or not. But we know in actuality what were the possible options of what that hula hoop did. It did or it didn't, right? So what are my 2 probabilities of what actually happened? Was probably that what is if I wanted to get it and I didn't, that was 0. Or it did get it, that was 1. But it's already happened, right? I did or I didn't. So my probabilities of getting it were actually 0 or 1. I just don't know which one it was. Does that make sense? It happened. I did it. I never know if I did or didn't. All right, so this first one, there's a 95% probability that the interval from 107.8 to 116.2 contains mu. This is saying that this probability, I directly relate it to this one specific interval. Is that correct? Am I 95% sure that it's between 107.8 and 116.2? No. The 95% only applies to if I threw hula hoops all day, 95% of them would capture it. The 95% does not directly relate to my one interval. And I talked about this yesterday. On this page, writing confident that is basically saying, asterisk, side note, I mean this. So I am saying that 95% applies to if I did all possible samples of this size from this population. The 95% does not directly mean that I am 95% sure that it is directly between the two numbers that I found from only one sample. That is the big thing here. So A is wrong. When I threw that one hula hoop that got me 107.8 to 116.2, I actually threw the hula hoop. It actually did or it didn't. So what would my probabilities actually be that I just said? 0 or 1. So the probability that it's between 107.8 and 116.2 is 0 or 1, but I'll never know which one it is. But it is not 95% sure that that one interval captured it. That's the big thing. That's basically the whole thing that this problem comes across. Okay, what about B? B looks the exact same as A, except it now says X bar. How did I come up with 107.8 and 116.2? Margin of error from the X bar. So X bar is my dot that I started with. And then I make my green dots out here. This question is asking, what is the probability that that orange dot is in this interval? Well, that answer is what? 100%. I made the interval from X bar, so X bar is definitely going to be in the interval. So B is wrong because we are 100% sure that X bar is an interval. That's how we made that interval. Questions on that? C, this interval was constructed using a method that produced intervals that capture the true mean in 95% of all possible samples. Yes, no, anything bad, anything good? Guesses? The only thing I would possibly add to this, now this one is technically true, but what would I add to all possible samples? And I think it should have had that included on the end to be more specific. D, 95% of all possible samples will contain the one interval 107.8 to 116.2. True or false? That doesn't sound right at all. They're not all going to be the exact same. They're going to be different. So that one's just completely wrong. E, the probability that the interval 107.8 to 116.2 captures mu is either 0 or 1, but we don't know which. That's the one I've just talked about 4 times in a row. That one is true. Because what did I just say at the beginning of starting these problems? I threw the hula hoop. I either got what I wanted or I didn't, and I'll never know which one it was. But it's already happened. So I either got it or I didn't. I'll just never know if I got it or I didn't. If you have questions, I need you to ask questions. Yes.
Wait, why was D?
D was wrong. So this one is basically, I think the wording of this one's funny. It's basically trying to say that 95% of them will be exactly this interval, and you're going to have variation in it. Other questions with this problem? Like, I'm taking time to spend a lot of time on this problem on purpose. Yeah.
Can you explain A again?
Okay, so A and E are talking about the same thing. I threw that one hula hoop. There's not a 95% chance now that that one hula hoop landed because it either did or it didn't. So you can't ever apply your 95% directly to my one interval that I just made. You only apply the 95% if I threw hula hoops all day. 95% of the hula hoops would be there. Questions? All right, 20. Part of this one I wish I wouldn't have done, but it's not that serious. It says, which of the three inference conditions, what do I mean when I say inference conditions? Normal, independent, and random. That's why I said on the 4-step process, I write check conditions. It's not so that you make sure you write the words check conditions, it's that you understand those are the conditions. So first one, random. Does random occur here? An online poll was posted. No, it's not random. If it's not random, what can we not do with it? This goes chapters back. Can't generalize our results to the population. What's another condition? Independent. How do we check independent? 10% condition. What's our N? What's our lowercase n? Sorry. Sample size, which is 20,125 people. What do I do with that? So the 201,250 people, that's how many people could have responded. Would be our P, or 201,250 people. Are there at least that many people, or that many people who could have responded? Yes. So 10% condition checks out. What's our other condition? What have I not written yet? Normal. We didn't talk about this one yesterday, but it's the same one as chapter 7. How do I check normal if it's proportion? N times 1 minus P and N times P. You're checking both of those. If you didn't do that part today, that's fine because we hadn't brought that up again. But that's all it does there, and it's 73.5% of this many. If you have this many people, you're going to have at least 10 successes and at least 10 failures. That shouldn't be an issue. All right, 21. We are comparing a 99% confidence interval versus a 90. So our 99% confidence interval is wider or narrower than a 90%? Wider. So it's definitely wider. If it is wider, am I more or less likely to be incorrect? Less. So I've made it bigger, so I have more numbers that can be included in there, so I have a smaller risk of being incorrect. Your answer is B. This is something that we've actually talked about before a while ago, but you still should be able to get this. what is some people refuse to answer questions? Just let's go back to chapter 4. What's that word? Non-response. People without telephones could not be in the sample. Under coverage. Some people never answered the phone during several calls. It's not really a specific word for it. It's kind of just non-response. All of these are talking about what in general? Bias. That margin of error, why do I have a margin of error? So like if I do one sample, why is every sample not going to be the exact same? So by chance, right? So there is going to be chance variation. Margin of error only accounts for chance variation. So if your thing is biased, margin of error does not account for that. And that's what you need to know about 22 is it only accounts for chance variation. All of these are biased, so it doesn't account for any of them. So your answer will be E for this one. All right, 23. Now this one is basically the same thing as 19 or 18. You've measured the systolic blood pressure of a simple random sample of 25 company employees. 95% confidence interval gives us 122 to 138. Which of the following statements would be a valid interpretation? Am I directly applying? Well, this one says 90% of the sample. Well, I'm definitely not applying 95% to the sample. This one is applying 95% to our one interval. Is that what I do?
Wait, why is it a thing?
This is 95% of the sample.
Is that not what it is?
No. I found an interval from the sample, but you're not saying 95%. Say that again. This is our interval from the sample, but that doesn't mean 95% of the people I interviewed were that.
I was calling each little intervals.
Okay. Of the samples. Is that what you're thinking?
Yeah.
Okay. Yes. So yes, that's your reason. That's of this sample. If this procedure were repeated many times, 95% of the resulting confidence intervals would contain the population mean. Yes, no. Probability that, so directly applying the probability to this one interval, no. If this procedure were repeated many times, 95% of them are exactly that one, no, because there's variation. The one thing that's implied in this procedure is the fact that they are doing this many people every single time, which is if this procedure. So your answer is C here. And the last one. So I started with a 95% confidence, 95% confidence and switched to 90, switched to 80. The margin of error. The margin of error for 80%, and I have to write stuff out like this so I don't get mixed up because I want to write it the exact way the problem's asking. So in an 80%, is that going to be wider or narrower? Well, it's asking about margin of error. So margin of error is literally how wide it is just on each side. So my 80% is going to be what margin of error in relation to this one? Well, it's going to be narrower, so my margin of error is less than. Is it less than because we require less confidence, or is it less than because our sample size is smaller? Because did it tell us anything that we changed the sample size? So your answer is B.